Okay, so welcome back. And so now we're going to talk about the general form of these cyclic or periodic functions. In fact, functions that behave this way are called sinusoidal functions. And so the two general forms of sinusoidal functions are one of these two that I've written on the board. So either it's going to be a sine bx minus c plus d, or it's going to have the same thing but with cosine. So notice that, again, this is just like any function. We've got multiplication inside and outside the function, and we've got adding and subtracting, right? So we've got compressions, vertical and horizontal compressions and or stretches, and horizontal and vertical shifts. That could happen, right? So again, if A was 1, B was 1, C was 0, and D was 0, then we'd have the basic sine and cosine function. Okay, so these are the general form of what we call the sinusoidal functions. Okay, now the period. Now we can see, we know the period of a sine x and cosine x is 2 pi, right? Okay, what affects the period is going to be b. B affects the period because it's inside the function. Now A affects what we call the amplitude. We'll talk about that later. But B, which is a factor which is being multiplied by x, this is what does this affect? Well, think about it. This affects the horizontal, right? It either will stretch it out if B is what? Well, if it's less than 1, or if this is greater than 1, it'll compress it. So if B is greater than 1, it squeezes it horizontally. It's a compression. If it's less than 1, then it becomes a horizontal stretch. So for example, if we, and by the way, the period that we're going to use, the period, B is represented by the period because what we're going to do is we're going to take 2 pi, right, which is the period if B was 1. And so what we're going to do is we're going to take this, and the period of the general sinusoidal function is going to be 2 pi divided by the absolute value of B. Okay? And that determines the period. So, for example, if B is greater than 2, or excuse me, greater than 1, then what happens? Well, for example, if it's 2, right, then the period is pi. So think about it. What does that mean? If B is 2, right, if B is 2, then what happens? It cancels with 2 and the period becomes pi. So that means that every pi, not 2 pi, but every pi, it will repeat the pattern. So for example, which one of these would represent a pi, a period of pi? Well, which one repeats the pattern every pi? Well, it's going to be what's in red, right? So in red, you start down here. So this is a cosine function, right? So this is cosine. Okay? So a period of 2 or a period of 1, a period of pi would be start here and from here to here. So what's the horizontal shift to go from here to here? Well, it's pi. So the red graph represents the case where B is 2. Okay, because then the period, if B is 2, becomes pi. Okay. Now, what if B is less than 1? Well, that's going to be a horizontal stretch. So that means, what, for example, what if B is, instead of 2, it's 1/2? Well, that means then the period would become 4 pi. So now, instead of repeating the pattern 2 pi, every 2 pi, it's now going to be 4 pi, which means it's going to be the blue line. Okay? So now, it's going to go all the way to 4 pi before it gets back to 1. So it's going to go back up to 1 here at 2 pi, right? And so at 4 pi. Okay, so only half of it is at 2 pi, right? And so then the other half will will finish up at 4 pi. Okay, and then of course, so here's the sine, for example, sine of x over 2, right? Where b is 1/2. And the red would be represented by, for example, or no, not sine, cosine. This is cosine. Cosine of x over 2, and so this would be cosine of 2x, for example. Okay, and then the black curve is just our normal cosine x with a period of 2 pi. And so that's how the period affects the graph. Remember, whatever's inside the function affects the horizontal. So b affects the period. C just affects the shift, okay? Whether it shifts right or shifts left, right? So just don't forget what you know from transformations, okay? And then likewise, outside the function affects the vertical. So that's A affects what is a vertical compression or expansion or stretch. Okay, so that's what we call amplitude, right? Because the range typically of a sine or cosine function goes from -1 to 1, unless you have A out here, which is different from 1. Okay? And then of course you've got your vertical shift too. So again, don't forget what you learned about transformations. It all applies to any function, and just like including sinusoidal functions. Have a great day.